Hi everyone, welcome back. In today's video, let's look at how our passwords are stored in the server or the websites which we use, right? So password is a sensitive information and we are always worried how the companies handle our passwords. If if some hacker attacks the company's database, will our passwords be compromised, right? So we can look at today like how passwords are or must be stored, right? So when is password needed? It is pretty straightforward, right? So you have your system and then you sign up to a website, right? So in the sign up page it asks you to give a username and password, and then you give a username, password and email or whatever it is, and the website will have its database or DB where it will say, hey, for username 1, this is the password. For username 2, this is the password. So this is the straightforward approach, right? So when you request for another request, right, say asking, give me my balance, say it is a bank website. So now what will it do? So your bank's server will go and check for your username what is the password, and it will check if the password and username matches when you try to do a give me balance along with the login page, right? So if when it finds that the username and password is good, then it will fetch the details of your username and it will give you the balance. So this is straightforward, but then this approach is not really secure. So why I'm saying is that, say if someone attacks this database, they will be able to get your password. Also, there is high chances that we reuse the password across multiple websites. So once someone knows your password and username or email, they can go and hit almost all the websites: Facebook, Instagram, Amazon Prime Video, so Amazon, so everything they'll go and try to hit with their username and password to see if it logs in. So if this is compromised, almost everything is compromised. So what are the bad things about storing the passwords in this way, or what are the things which we should avoid? Is good websites never store your password. So this is important. So good websites, they don't care about your password, or not care, but don't track your password. So they don't store it in plain text, which we saw. Plain text is if you have your password as password 123, storing it exactly in the database as password 123, that is not at all good, because it can be, if database is compromised, attacker will doesn't have to do any effort and they will be able to access your password, not even in encrypted. So why not encrypted? So if you don't have the previous understanding of encryption, encryption means juggling your password, right? And then this is done using a algorithm and a secret key. So if you want to know more about encryption, you can take a look at https video. So encryption is like if you have 123 as a password, then it goes into a function or encryption algorithm, plus it has a secret, and then it gives you a random number 7 8 something like this. So only with this secret and of course the reverse function you will be able to get this from this, right? But still we don't want to store it in encrypted, because if the secret gets compromised as well, the attacker will be able to get this 123 from this. So right, so not even in plain text and not even in encrypted, not in any readable form, right? So they should not be able to get your password from this. So for this, what they introduced, or what is the approach that came, is hashing. So I would have explained hashing in any other video in general, but this is one of the main use cases of hashing. So what hashing does is, so it takes your password, has a hashing function, and it gives you a random fixed length output or a random identifier. So it is similar to encryption. So if you give 7 8 9, only in the case it will only it is similar to encryption in the case that if you give a random number password, it will give you a equivalent random integer, right? So it will give you something like this. So what is the difference between hashing and encryption? So the main part that is missing, you can see, is secret. So there is no secret in terms of hashing. And another important thing that comes with removing the secret is this is one way. So from 1 to 3 you go to 7 alpha, the random number, and with the secret and reverse function in encryption you can get this 1 to 3 back. But in hashing function, if you give 789, this will give this to you, but you cannot use the same hash function or any function to get the 789 back from this one. So once you change it to this and store it in the database, even if the attacker has this and knows what hashing function you are using, they will not be able to get 789 back from this. So that is the key idea of it, is that it is one way. So no going back to your password from the random identifier. So the idea is that all the good websites, all the secure websites only store your hashes in the database. So how it will work is that, let's go into the fill thing again, right? Now we are going to see the reversed or the revised flow with hashing on how your login works. So initially we saw a straightforward approach without hashing, that passwords are getting stored in the database. So now nothing much changes here. So you have your client, your username, your computer or your laptop or your mobile, and then here you have your server. It can be Google server, right? So in the sign up page, what you do is you send your username and password. So here what happens is the username and password goes into the hashing function, and then a hash is generated, and in the database, this can be Google, and in the database along with your other details in the password field, what gets stored is the hash. So the Google doesn't even maintain your passwords. So the first thing Google does is changes your password, gives into a hash function, generates the hash and stores the hash. So now in the second step, what will you do? During login, you again send the username and password, right? So Google again what it does, it puts the password into the hash function, generates a hash and compares the hash with the hash in the database. If the hash matches, then it will say, hey, you have successfully logged in. So your passwords are never stored anywhere in the database or on the server side. So this is a secure way to store the passwords, and this is how most of the companies do store your password. So we already saw the difference between encryption and hashing. So for the purpose, the only reason or the advantage of hashing is that it is one way, you cannot get the password from the hash. So even if the secret, somehow the hacker got it in encryption, they can get your password back. Here there is no way. So in addition to this, some things can happen. So what the hacker can do is, if you have like a basic hashing algorithm, so what they will do is they pre-compute the passwords and the hash combination. So they will maintain a table, hackers, called a rainbow table. So here what they will do is, so this hashing function which the Google uses is pretty open. So Google will say that, okay, this is the function which I'm using. So if it is using a base function, like a basic function, not very strong, so hackers can pretty much easily, what they will do is they calculate the hashes for common passwords like password Arjun123 123. So for these things they pre-compute the password, so they will write the hash according to it, 7BC. For this algorithm they will do the same, 10A exclamatory. So they will pre-compute this, and then when they compromise a database and have all the hashes, they will give that as an input to this rainbow table, and this rainbow table will pretty much say, if any hashes match, hey, this is the password of this. See, if you have kept your password as password 123, which is not a good idea, so password 123 they would have already calculated it, and then they will go into this table again using a script, not manually, so and ask for, hey, if there is any hit for this hash map. So if there is a hit, it will give you the password that this user is using the password Arjun123 or password. So on this password front, that is why we need to follow certain things, right? So the first one is long passwords. Always use long passwords, so that it's harder for them to do a pre-computation, right? The second one is never reuse, no reuse. So if you use the same password across multiple websites, even if one database got compromised, they will take the password and try to hit all the major websites where the users usually have traffic, right? So instead of reusing the same password across all the websites, you can use some password manager to, work out your passwords. So what are the other things you can do is, another thing is enable multi-factor authentication. So there are various ways to do it, like they can send you a message, they can send you an email. So I have made a video on multi-factor authentication to let you know like what is the easy and the most secure way to do is. So one such way is using a authenticator app itself. So it's super secure, so you can turn it on for all your websites. So even if your password is compromised, the website is going to ask you for the MFA, and when the MFA reaches your phone or your laptop, you will know that someone has compromised your password in that particular website, and you can pretty much go and change it. So these things you can follow. so that in addition to hashing and other things, this will help you to slow down the attacker or be aware even before the attacker can use it across other websites, right? So how can we avoid this rainbow table? So for these things as well, some security things are added on top of hashing. So one thing is called salting. So even if you give like basic passwords like password 123, and another user also has given the same password as password 123, so what Google will do is when a user signs up, they will assign a salt for them. Salt is like a small random integer. It can be 0, 7, exclamatory, tilde, something like that, and they will store that in the database as well, salt. And they will do hashing on both the password and the salt. So your hash function will look like this: hash function of password plus salt. So now what is the advantage? Your password will your hash will be even more random. So if hash function is happening directly on password, it will give the same result for all the similar passwords. Say you have password as password 123 and another user has password as password 123, this hash will be the same. It will be 7BC here. But by adding a salt and putting it into the hash function, even you and another user has the same password, the hash will be different. So if the user looks at the hashing table, to build this rainbow table, it is even more harder because they need to guess the password plus salt as well. So this salting concepts makes it super hard to build a rainbow table because they can only guess the common passwords but not the salt, right? Another thing which they introduced or slowly built up is strong hashing algorithms. What strong hashing algorithms do is make it slower. So this rainbow table or hackers depend on the fast output of the hashing algorithm. Say they give millions of records, they want the millions of records to be completing hash and give them back the table. But the current algorithms like bcrypt or bcrypt, ascrypt, argon, so these are strong hashing algorithms which makes the process slower. Say if the hacker is using a very GPU intensive computer to generate, thinking that I will generate all the hash pretty fast, so this is written in a way that it puts some hard requirements on the hardware or expectations that whatever the hacker does, generation of this hashes are very slow. So in order to generate a lot of passwords, they need to spend a lot of cost in it and time in it, which makes it little bit harder for them to proceed with this process, right? If it is easy, you give your list of passwords and it gives you hash the next seconds, of course they are motivated to continue with the attack and keep trying. But these things make it slower and resource intensive, that it is little bit harder for them to pre-compute these things and proceed with trying to do the attacks. So yeah, that is pretty much it. So hashing and combined with salting and slower algorithms makes your password as hard as possible for the hackers to get it. But in addition, even if they compromised it somehow, you still can follow these things like keep long passwords, do not reuse, and always enable MFA. Even for your Instagram you can do that, so that you are secured to the best limit possible. Yeah, let me know if you have any questions and we can meet in another video. Thank you. Bye.